Hello everyone. Today we will continue to learn the 10th part of the chapter on concrete materials, building mortar. We will first learn the definition of building mortar, which is a material made by mixing and hardening cementitious materials, fine aggregates, admixtures, and water in appropriate proportions. Mortar plays a role in bonding, lining, and transmitting stress in construction projects, mainly used for masonry, plastering, repair, and decoration engineering. According to different purposes, it can be divided into masonry mortar, plastering mortar, decorative mortar, and special mortar. According to the different cementitious materials used, it can be divided into cement mortar, lime mortar, cement lime mixed mortar, and polymer cement mortar. Masonry mortar refers to the mortar used to bond bricks, stones, blocks, etc. into masonry. In masonry structures, which is called masonry mortar, it plays a role in bonding blocks and transmitting loads, and is an important component of masonry. Its constituent materials mainly include cement is the main cementitious materials for mortar, and commonly used cement varieties include ordinary Portland cement, slag Portland cement, volcanic ash Portland cement, composite Portland cement, etc. In construction projects, due to the low strength grade of mortar, in order to make responsible use of resources and save materials, it is necessary to choose low strength grade 32.5 cement and masonry cement as much as possible when preparing mortar, due to the use of additives such as lime paste in cement mixed mortar, which can reduce the strength of the mortar. It is specified that cement with a strength grade of 42.5 can be used for cement mixed mortar. In addition, sand for mortar should meet the technical requirements for sand for concrete. Using medium sand to mix mortar can not only meet the workability requirements but also save cement, so medium sand is preferred. Due to the thin layer of mortar laying, the maximum particle size of sand should be limited. The maximum particle size of the mortar used for brick masonry should not exceed 2.5 mm. For mortar used for rubble masonry, quartz sand should be selected, and its maximum particle size should be less than 1/4 to 1/5 of the thickness of the mortar layer. The mortar used for plastering and pointing should be fine sand. The mud content in the sand affects the quality of the mortar. If the mud content is too high, it not only increases the cement content of the mortar, but also may increase its shrinkage value and reduce its durability. Therefore, for masonry mortar with a strength guide of M2.5 or above, the mud content of the sand should not exceed 5%. The cement mix mortar with a strength grade of M2.5 should not contain more than 10% mud in the sand. For areas with abundant resources, such as artificial sand, mountain sand, and ultra-fine sand, mortar can be reasonably utilized to reduce engineering costs. However, It should be tested to meet technical requirements before use. For additives, in order to improve the workability of the mortar and reduce the amount of cement used, some inorganic materials such as lime paste, clay paste, electron gypsum, fly ash, etc. are usually added to the cement mortar. When quicklime is matured into lime paste, the pore size should not exceed 3 mm times A. 3 mm mesh filter should be used for filtration, and the curing time should not be less than 7 days. The curing time of ground quicklime powder should not be less than 2 days. Measures should be taken to prevent drying, freezing, and pollution when storing lime paste. The application aperture of calcium carbide slag for producing electrogypsum should not exceed 3 mm times A. 3 mm mesh filter should be heated to 70 degrees and maintained for 20 minutes during inspection, and it can only be used after there is no smell of acetylene. Hydrated lime powder should not be directly used in masonry mortar. The quality indicators of fly ash and ground quicklime should comply with the requirements of the national standard GB 1596-2005. Fly ash used in cement and concrete. For water, the water used for preparing mortar should comply with the current industry standard, concrete water standard, for admixtures, substances added during the mortar mixing process to improve the performance of the mortar. For the technical performance of masonry mortar, fresh mortar should have good workability, and the hardened mortar should have the required strength and adhesion to the base surface. Without excessive deformation, mortar with good workability is easy to spread into uniform, thin layer on a rough masonry foundation, and can tightly bond with the bottom surface. It is convenient for construction operations, improves production efficiency. The workability of mortar includes two aspects: fluidity and water retention. First, strength grade and apparent density of mortar. The strength grade of mortar is determined based on the average compressive strength of a 70.7 mm cube, cured for 28 days under standard curing conditions. The strength grade of masonry mortar can be divided into 7 levels: M5, M7.5, M10, M15, M20, M25, and M30. The apparent density of the cement mortar mixture should not be less than 1,900 kg per cubic meter, and the apparent density of the cement mortar mixture should not be less than 1,800 kg per cubic meter. The fluidity of mortar refers to the property of mortar flowing under its own weight or external force, also known as consistency. Measure the consistency of mortar using a mortar consistency tester, expressed as the immersion value. The standard cone is freely immersed in the mortar, and the immersion depth of 10 seconds is the consistency value of the mortar. Large sinking degree and good fluidity of mortar. But if the fluidity is too high, the mortar is prone to layering and water separation. If the fluidity is too small, It is not convenient for construction operations, and the mortar joints are not easy to fill tightly, which will reduce the strength of the masonry. For water retention, it refers to the ability of freshly mixed mortar to maintain internal moisture. Mortar with good water retention properties can effectively retain moisture during storage transportation and use preventing rapid loss of moisture. It is easy to layer uniform and dense thin layer of mortar during masonry and plastering, ensuring good adhesion and high strength between the mortar and the base material. The water retention of mortar is measured using a mortar layering tester, denoted by the layering degree. Firstly, measure the sinking degree of the evenly mixed mortar, and then load the mixture into a layering cylinder. After standing for 30 minutes, take the bottom 1/3 of the mortar and measure its sinking degree. The difference in sinking degree between the two measurements is the layering degree value of the mortar. The layering degree of mortar should be between 10 mm and 20 mm. If the layering is too large, the mortar is prone to segregation, making it difficult for construction and cement hardening. Therefore, the layering degree of cement mortar should not exceed 30 mm, and the layering degree of cement mixed mortar should generally not exceed 20 mm. However, if the layering is too small or close to zero, the mortar will become dry and thick, which can easily lead to shrinkage cracks. The bonding force of mortar is mainly manifested in masonry is the use of mortar to bond many block-like masonry materials into a whole. Therefore, the strength, durability, and seismic resistance of masonry depend on the size of the mortar bonding force, which increases with the increase of its compressive strength. In addition, the bonding strength of mortar is related to factors such as the surface condition, cleanliness, wetting condition, and the construction and maintenance conditions of bricks and stones. The surface of the base material is rough and clean, and the bonding force of the mortar is strong. In addition, there are certain requirements for the deformation of mortar. During the process of setting and hardening, as well as under changes in load or temperature and humidity conditions, mortar will undergo deformation. If the deformation caused by the mortar is too large or uneven, it will reduce the quality of the masonry and cause settlement or cracks. The shrinkage deformation of mortar mixed with lightweight aggregate is greater than that of ordinary mortar. The consistency, water retention rate, and compressive strength of masonry mortar must also meet the requirements. Plastering mortar refers to the mortar applied to the surface of buildings or building components, collectively referred to as plastering mortar. Its characteristics include the plastering mortar has the ability to protect the base material, meet usage requirements, and have decorative effects. According to the different functions of plastering mortar, it can be divided into ordinary plastering mortar, decorative mortar, waterproof mortar, and plastering mortar with certain special functions, such as waterproof, acid resistant, thermal insulation, and sound absorption, etc. Requirements for plastering mortar. It has good workability and is easy to apply into a uniform and flat thin layer, making it easy to construct. It is necessary to have sufficient binding force, which can firmly bind with the base material and prevent cracking or peeling after long-term use. In terms of characteristics, the composition materials of plastering mortar are basically the same as masonry mortar, but sometimes some fiber reinforced materials, such as hemp knife, paper reinforcement, glass fiber, etc., are added to improve the tensile strength of the plastering layer, increase the elasticity and durability of the plastering layer, and prevent cracking of the plastering layer. Sometimes adhesives such as polyvinyl foam adhesive or polyvinyl acetate lotion are added to improve the strength and flexibility of the surface layer, strengthen the bonding between the mortar layer and the base material, and reduce cracking. For ordinary pastry mortar, it is a commonly used mortar in construction engineering, which can protect the building from harmful media such as wind, rain, snow, and the atmosphere, improve the durability of the building, and make the surface flat and beautiful. In addition, the decorative mortar that has a beautiful decorative effect applied to the surface of the interior and exterior walls of the buildings is collectively referred to as decorative mortar, and a special mortar includes, first, waterproof mortar, second, insulation mortar, and third, sound-absorbing mortar. The above is our explanation of building mortar in this class. That's the end of this lesson. See you next time.